Good afternoon, everyone. Thank you for joining us today. Hope you've had a fantastic reInvent so far. My name is Prateek Sharma. I'm a Principal Solutions Architect at AWS. I've had the unique pleasure to work closely with these folks, the security folks at Netflix for the last 5 years. And a couple of years ago, in reInvent 2022, we started a conversation on reimagining multi-AWS account deployments with security and speed in mind. In these intervening years, we worked together with Netflix and collaborated on an idea which we are going to talk about today. And these folks worked hard and made quite a lot of progress and had a lot of learnings. Before we dive into the topic, to give you a quick recap, Netflix adopted AWS in 2008, and their early growth happened in a handful of AWS accounts. Netflix realizes that this is not sustainable, and they want to take advantage of multi-AWS account architecture to reduce operational and security risk, improve developer experience, and adopt best practices. AWS accounts, as you all know, provide strong isolation boundaries, and multi-AWS account deployments allow you to logically lay out separation of concerns and reduce the scope of impact. Leaning into this, Netflix collaborated with AWS and came up with an innovative approach that we discussed in our talk in 2022. The QR code here, if you haven't seen the talk, please check it out, click a pic. It's excellent. And historically, the top triangle that you see here has been welded together with a strong coupling between AWS accounts, IAM roles, and compute resources, and for valid reasons. And Netflix tried previously a few times to migrate their workloads from a few handful of large accounts into smaller ones, but moving compute resources along with all the roles and everything else that those resources touch is quite a task. And this is where Netflix came up with a new idea. And they proved the feasibility of an interesting technical approach where we were able to decouple IAM roles from AWS accounts containing compute resources, while taking advantage of the strong isolation boundaries that AWS accounts offer. So this has become the cornerstone of Netflix's massive multi-AWS account journey. And with that, I would like to introduce two of the smartest folks that I've ever met. They are extremely smart security engineers, Joseph Kerr and Patrick Sanders. They're part of Netflix's cloud infrastructure team and a cloud infrastructure security team. And they've put in a lot of work making this a reality. So let's dive deeper. Joseph, over to you.
All right, you can trade you. Thank you so much, Prateek. It's a pleasure and privilege to work with Prateek. Everyone who knows him can vouch for that. And it's a pleasure to see each and every one of you here today. It's a rare treat to have folks excited in these topics. Probably the only time we can talk about something like this and get genuine excitement. Our family members mostly give us blank stares, right? So when we're talking about why we're here today, the second of these existential questions, a lot of it comes down to the problems of the present, right, which are rooted in these large monolithic accounts that are home to many, many workloads. And when you have accounts like that, this picture becomes a sad inevitability. You have access between applications or workloads that doesn't make sense, right? Everything can access everything else because trying to granularly create, strong security isolation between each of these things in an account set up like this is incredibly time-consuming, complex, and just downright painful. And user access is another layer of complexity on top of that, right? And so achieving anything remotely resembling right-sized access is very, very difficult. And if you are the central security team, like we are, you have a lot of touch points to deal with, right? Resource policies on every single piece in there, IAM role policies, trust policies, the policies that govern user access. You have to granularly manage all of it. And it's just not scalable. The only thing missing from this graphic, I think, is the fountain of tears coming from the panda feeding into a giant reservoir, right? and we can't do this anymore. So where are we going? Both in this talk and at Netflix. Hopefully to a world that looks a bit like this. So Pratik introduced the concept that we talked about last time of carving off IAM roles from the compute resources, decoupling that formerly welded link so that we could structure our accounts as pictured here, right, where each workload lives in its own isolated account that we call dedicated application accounts, while the compute and network infrastructure, those really heavy, complex anchors, stay where they are. With this picture, we're not telling you need to centralize all of your computed network in one account, right? Please don't take that as the takeaway. The point is that if you can isolate the workload, the application, IAM roles, you get flexibility, right? You don't have to touch these things if you don't want to. And if you do want to, you can organize them in ways that were never possible before. So you can open up some really exciting possibilities for your compute and network infrastructure along the way. So for us, this was a really big bet with a lot of unknowns. It sounds great in theory, but how do we get there in real life was the problem that we've been faced with over the last couple of years. And if we do manage to get here, then will it have been worth it? And this is a common theme for all of us as security engineers, right? We hear interesting technical ideas, but leveraging them to drive major change in complex enterprise cloud environments, well, that's another story. Thankfully, that is the story of today's talk. So we'd like to talk about how we've closed the chasm between the interesting idea and enterprise-grade implementation. And so we hope that you leave today with actionable patterns and inspiration for your workload and account isolation strategies. So before we can run, we have to crawl and walk and so on. So there are some foundational technical capabilities that have to be in place before we can move even the first workload to the pattern in the previous picture. And one of the most crucial technical linchpins is account-agnostic credential delivery. So we're going to pack a lot into this brief slide, but there's more on this in the previous talk that Pratik alluded to. But essentially, you need some way for AWS IAM to trust your internal token issuer or certificate issuer. And you need a way to leverage that to deliver arbitrary IAM role credentials to your workloads. And why do you need this? Because when you launch an instance via the EC2 API or the web console, AWS asks you, what role do you want to associate with the compute instance? You cannot select a role that does not live in the account. And so this is where a solution like this comes in. The way we chose to approach the problem is by building a lightweight OIDC provider, where we use a very simple setup of an S3 bucket fronted by CloudFront. CloudFront adds a bit of extra resilience there as it allows us to configure a failover bucket, things like that. The S3 bucket just hosts our public JSON web key set and OpenID configuration. Once that's in place, we can configure the IAM service in each of our accounts to trust that very lightweight OIDC provider. And that way, tokens that are signed by that OIDC provider and issued by our internal token issuance service will be valid in the eyes of AWS IAM. The last piece of this is the IMDS proxy. So when you have application code running in EC2, running on your container platform, if it's using the AWS SDKs, it's going to use the default credential provider chain to attempt to discover IAM role credentials. We didn't want to force any code changes as part of this strategy, right? We wanted things to be completely transparent to our application owners, so it was imperative that we preserve that native expected behavior. So we built a custom IMDS proxy that exchanges those internally issued tokens for IAM role credentials using the STS assume role with web identity API, and exposes those on the IMDS proxy. And when the application, the AWS SDK, looks for credentials, it finds them right where it expects them. But the credentials that it finds are now up to us, right? We can house them in whatever AWS account we want. There are other ways to solve this problem, and one of these alternatives might be a better fit for you. A good option is IAM Roles Anywhere, which is a relatively new AWS offering, and you can use that in conjunction with an IMDS proxy or an external credential process to achieve a similar transparent means of arbitrary credential delivery. IAM roles for service accounts in Kubernetes are also usable in this fashion, right? Those are also OIDC based, so that's a viable alternative. So a second key capability that you'll need prior to migration number one is a way to reason about your targets, right? What apps am I going to target? How am I going to group them and reason about them? And we found that keying in on migration complexity was really, really helpful. And so for each of our applications, we tried to estimate these three things, right? Migration complexity, security risk, and operational risk. And we found that we were able to get the most leverage by targeting apps with, high security risk, but very low migration complexity. And leverage in this case meaning risk reduction to effort ratio, right? We don't want to spend a month migrating a single app that's really complex, when in that same time we could migrate 50 that are much simpler. So this has been a really helpful way for us to think about what applications we're going to target and why. Another note here is that if you have metadata about your internal applications, it's very, very useful. So for example, we keep track of some certain application characteristics like, is this application internet facing? Is it part of our critical streaming path for getting video on demand to customers? All of those types of things can help you reason about the security and operational risk and complexity. Finally, you're going to need some technical bits to make the actual migrations happen, right? Moving the application or moving its identity to a new account. This is going to necessitate some type of CD hook, and that's going to be a very business logic heavy part of this solution. So it's hard for us to recommend exactly what that should look like for all of you, but some way to hook into your system for deploying applications, performing rollbacks if needed, that sort of thing. And start simple, right? For migration number one, maybe that hook is just a Slack DM to the application owner saying, hey, can you please redeploy this for us? You're going to need a robust account vending solution. You should be able to push a button and get an AWS account. We talked more about our account vending machine in detail in the previous talk, but an important note here is that you should also have a mechanism not only for provisioning the account and vending it out on demand, but for recording all of the information about who did I give this account to, who is the owner, what workload or workloads is this account associated with, and we highly recommend using some type of account inventory system to do this. Don't recommend trying to use things like account tags to carry all of that metadata, as using the organization's API for that is a bit cumbersome and doesn't really scale super well. The last thing on this list, you'll need some sort of on-off switch for that new credential delivery mechanism we talked about that makes it easy to toggle the new credential delivery behavior versus fall back to what AWS does by default. And later, we'll talk about scaling each of these things up. Now, we've just covered a lot of things that you need to do, right, just to get to migration number 1, and it's probably a little bit daunting. So it's important to remember what we don't need to do if we can meet these other requirements. The biggest thing is that it keeps us sailing far and wide from the networked migration monster, which has devoured many a poor cloud engineer. We don't need to manage network infrastructure, right? We don't need to move EC2 instances. We don't need to move data stores. We don't need to extend VPCs into each new account that we create. We don't need to worry about routing rules, NACLs, security groups, DNS records, like the list goes on and on and on and on. And anyone who's done a heavy multi-account migration is probably all too familiar with many of the pitfalls there. In short, these things are a really big deal in a brownfield or legacy environment. And so it's really nice to be able to just not have to think about these things as we go through our migration process. And so with that, I will hand things over to Patrick to talk about how we're measuring our progress as we migrate applications.
Thank you, Joseph. So let's talk about risk. Is everybody excited? Your favorite thing. All right, so let's go back to that example that Joseph showed earlier and dig into it a little bit more. So we've got 3 apps in the same account. Each one of those apps has 2 resources. That's 18 resources total. Nope, that's not right. Math is hard. But there are 18 paths between the application roles and the resources. But, sorry, I got stuck. So because of a long history of organic growth and overly permissive policies, we have all these access paths between the resources. But only 6 of those paths are necessary, assuming that an app only needs to access its own resources. All of the dotted red arrows we see are unnecessary access paths, and on top of that, all of these apps share the same AWS API rate limits. So at Netflix, we have a couple terms that we use to talk about risk in this scenario. Access exposure is the number of allowed paths between application roles and resources. In this example, we start with an access exposure of 18, but only 6 of those paths are required. 6 is better than 18 because lower numbers are better when we're talking about risk, right? But how do we know how good 6 is? For that, we calculate access efficiency, which compares intended and actual access. So if our exposure is 18, but we only need 6 of those paths, our access efficiency is about 33%. And if we can eliminate all but the 6 intended paths, then our access efficiency will be 100%. So when one app migrates to a dedicated account, we eliminate 8 of those edges, and that app gets its own AWS API rate limits. This leaves us with 10 edges, 2 in the app's new account, which we want, and 8 in the multi-tenant account. And now our access efficiency is 60% because we want an access exposure of 6, and we have 10. So we migrate another app, and we eliminate 4 more edges. So we started with 18, and we're down to 6, and those remaining are only intended access. So our access efficiency is 100%. Awesome. And as a treat, we've also mitigated noisy neighbor issues by giving each app its own AWS API rate limits. And you may notice that we only migrated 2 of our 3 apps, but we still realize the risk reduction benefits because there aren't any more apps in the same account that have cross-access to that app's resources. And this whole time, we haven't touched any of our compute infrastructure. All of it is in the same place. So let's expand this to 1,000 applications with 10 resources each, all in the same account. That gives us 10 million edges, and the first migration eliminates almost 20,000 of those. The next migration is a bit smaller than that 20,000, but it's still pretty big. This pattern continues with marginal risk reduction diminishing as migrations progress. And then here we can see something slightly unintuitive. Because of this pattern of decay, when we've migrated half of our applications, we've eliminated 3/4 of the access edges. So marginal risk reduction diminishes as migrations progress. So from a risk perspective, earlier migrations are more valuable and have higher risk reduction leverage. But what about access efficiency? Even at our halfway point, our efficiency is only 0.4%. This speaks to the difficulty of accomplishing meaningful risk reduction in a large, complex multi-tenant environment. So while efficiency is low in the multi-tenant environment, it's effectively 100% in all of the dedicated accounts that we're migrating to. So it's kind of a balance. We're eliminating a lot of access exposure, but our efficiency doesn't get much better in our big account, but it's great in our dedicated accounts. And some caveats here. This is way oversimplified. It's really difficult to measure actual risk, and this doesn't do it, but it gives us something to look at to see what kind of progress we're making. And similarly, we're only talking about IAM identity risk, so access to resources via AWS APIs. We're not talking about lateral movement over the network. That's a different problem that we're not specifically addressing here. So with all this moving around, we're gonna have to update some policies. It's inevitable, which is probably your second favorite thing after talking about risk. So what we want to do here is increase developer freedom and velocity in these dedicated accounts. We also want to simplify the control of resource access by taking advantage of attribute-based access control. And we also want to support infrastructure as code for our developers, which we've never really been able to do before because it's really scary in this big multi-tenant account where we have to keep a pretty tight grasp on IAM permissions. So we accomplish these goals in a simple and scalable way using a combination of service control policy, resource control policy, permissions boundaries, and ABAC. So let's talk about those organization policies, service and resource control policies. Because we can rely on the strength and robustness of account boundaries to prevent undesired cross-app access to resources, we can provide access. We can provide the apps and the app owners themselves pretty broad permissions within these dedicated accounts. And then we still use our org-wide organization policies, those SCPs and RCPs, to act as a backstop to prevent the big bad stuff like we protect our security-related services and infrastructure, prevent privilege escalation, lock down a tagging prefix, which is going to be very important in a couple minutes, and then limit public exposure of resources. And then the SCPs that are specific to the dedicated app accounts mostly just block anything VPC related because we want to prevent the proliferation of unmanaged network and compute resources. So these policies generally just kind of keep our org a safe place to operate. Next, let's talk about permissions boundaries. We have one large aim with our permissions boundaries, but we get a lot of other benefits too. In particular, we want to allow app owners to create and manage their own IAM roles. But we don't want them to be able to escalate their privileges and take over our security services or do other things that we don't want them to do. In the past, we've kept a really tight grip on all IAM right access. In fact, until this project, only our team has been allowed to create and manage IAM roles, except in very limited use cases. And we don't use IAM users at all if we can help it, and you shouldn't either. So with this new account strategy, we can delegate role creation and management to application owners, but only if there's a permissions boundary in play. The permissions boundary itself limits privilege escalation by requiring that any role under management has to have the same boundary attached. So in that boundary, we can also add guardrails, like preventing these roles from accessing resources outside of our organization. And we can also make sure that app owners can't create roles with more permissions than they already have. So with that, an app in a dedicated account can only access other apps' resources if explicitly granted permission in a resource policy. And even with star-on-star permissions, the app can only access its own resources by default within its account. So even without accomplishing anything close to least privilege, we've right-sized the IAM risk based on our risk tolerance. And finally, attribute-based access control. This allows us to make more generic policies and make sure that an app still has access to all of its resources during and after a migration. Normally, we would just update the policy on a resource to allow access to the application's post-migration role, but we don't want to do that as part of our migration process because that's another thing that could go wrong during the migration. And if we can do it ahead of time, then it just makes things simpler. So there's a problem with that, and I think that looking at an example will be the best way to show it. So here we have, on the left side of the screen, a bucket policy statement that allows access to a specific role ARN. In this migration scenario, there are two problems with this. One, we don't know the role ARN of the destination account, in particular the account ID, until the migration is at least in progress or probably until it's complete. And second, the principal in a resource policy has to exist, otherwise it'll be rejected by the API. So instead of doing this, we can add ABAC-based statements to the policy to allow access based on a protected principal tag and an OU path. And we protect that tag namespace using service control policy. So the example on the right has a wildcard principal with two conditions. One to limit access to principals in a particular OU path, and then the other that limits access to principals that are tagged with the app name reinvent app. So with strong controls on your app name tag, this policy can be read as allow access to this bucket for the reinvent app role in the test OU. And then if we want another app to be able to access this bucket, all we have to do is add its name to the tag condition. So this lets us keep our policies generic and acts as an idiomatic abstraction for our users. And with this pattern, we're able to confidently apply our resource policy changes ahead of migrations as part of the prep stages. So with our IAM patterns sorted out, let's jump over to some data gathering and planning for migrations. As Joseph mentioned earlier, we found that AWS service usage is a pretty good proxy for migration complexity. Some services like S3 and SQS are really easy to deal with cross-account because you can just update resource policies and everything's good. Others, like Route 53, CloudFront, the EC2 control plane APIs, are only accessible by a principal in the same account as the resource. So apps using these services that don't support cross-account access will need to be updated to assume a role in the origin account after they're migrated, which is a code change. So policy changes are cheap, code changes are very expensive, and so based on that, we came up with these three different complexity-based groups. First, apps with no AWS API usage at all. Those are really easy. They can migrate right now. Second, apps that use AWS services that do support cross-account access via resource policies. Those apps can be migrated with some simple resource policy updates, the ABAC policies that we showed. And then the third group are apps that use AWS services that don't support cross-account access, and those require code changes. So here we find ourselves with two similar but distinct data needs. To group the migration candidates, we need to know what AWS services are accessed by the app. And then for the migrations themselves, we need to know what AWS resources are accessed by each app. So the first is services, the second is resources. Services, easy. We call the IAM get generate service last accessed info for each role and store the results. The latter is a lot more challenging, especially at scale. So for management calls, we can derive the relationships from CloudTrail. That's pretty straightforward. Then we use S3 access logs to figure out which buckets an app is accessing. And then we kind of run into a problem because we would normally just enable CloudTrail data events, but it's pretty expensive. In fact, we did some math, and enabling data events for just S3 and SQS would add about 15% to our AWS bill, and our bill's already pretty big. So to work around this, we've developed custom AWS SDK instrumentation to inspect API calls and send usage data to our centralized logging platform. Some of my colleagues gave a great talk on this at reInvent 2022. QR code there if you want to watch it later. So we analyze this data that comes from the SDK instrumentation and generate a mapping of applications to the resources that they have accessed. And then along with that, we get a mapping of apps to their IAM roles from our continuous deployment platform. And then we also pull other metadata for applications like the internet-facing criticality, whether it handles sensitive data. And we put all of this together, and we have a pretty good idea of what resource policy changes we need to make and what things are interacting. And then there are also other operational benefits that we get from having this information about our applications. So we started gathering all this data, and we realized the first and second groups are most of our applications, actually. And so the most complicated migrations are the smallest group. So how about we just worry about those later? We can get more risk reduction leverage by focusing our automation efforts on the larger and simpler groups. So the first group requires no changes. Those can go now. The second group can be migrated with some simple policy changes, mostly resource policy changes, and then those can migrate also. And based on the graph that we looked at, we will have burned down quite a bit of our access exposure by that point. And then we make the big multi-tenant account a lot safer for the apps that are more complex and end up staying there for longer. So at this point, we've covered the basics of a migration, some risk-informed concepts for measuring progress, some IAM patterns, and some data juggling. So I'll hand it back over to Joseph, and he can tie it all together.
Thanks, Patrick. As you can probably gather by this point, stitching all of those pieces together for every single application you want to migrate is a hard thing to do by hand, right? And so we decided to write some migration orchestration tooling to help with this task. We ended up calling it Cloud Application Migration Platform, or CAMP, and its primary features are what you see here, right? It is basically our internal source of truth for the state of our migrations. It'll tell us which applications have not started, are in progress, or are done, which environments for which applications are done, what tasks have we executed on behalf of an application owner. It'll tell us what category of application or a given target is. So it'll tell us, oh, this is one of the simple ones, or oh, you don't want to touch this. And it's kind of our central place where we do all of our integration with external platforms like our continuous deployment in Spinnaker. Another really important aspect of CAMP is the validation it performs to ensure that the activities that we're conducting are safe. And so we'll walk through each of these, piece by piece. So Patrick was talking about data gathering, right? And so we've shoved all that data into a couple of places, right? Our big data platform and an S3 bucket that CAMP reads from. Again, those data sources are primarily our SDK telemetry, the IAM last accessed information about which AWS services each application is using, and our own internal application metadata with various qualities about each app. Now, applications are dynamic creatures, right? They're not the same from day to day, and so it's really important that we have a reconciliation process that accounts for those changes, right? What if today an application isn't using AWS APIs at all, but tomorrow it starts using S3 and SQS? Well, now our migration complexity has changed, right? And even more so if it starts using something like Route 53. So part of CAMP's job is to ingest this data on an hourly basis and update all of that information about our applications. So if that changes, we instantly know about it and adjust our migration plans accordingly. The next piece is our integration with Spinnaker, our continuous deployment platform. This is where we bake in those capabilities we talked about earlier, like redeploying applications, turning our new credential delivery mechanism, in our case, our IMDS proxy, on and off, and monitoring for application health to make sure that we don't break someone when we redeploy them, and we can do rollbacks if needed. An important piece here is that you should try to preserve as much, or you should try to leverage as much existing functionality as possible from your CD platform, rather than writing it into your migration tooling, right? It's much more robust for us to rely on Spinnaker's capabilities for deploying and monitoring than to try and implement those processes ourselves in CAMP. And that's been a really helpful pattern for us. And in our implementation, for example, we were able to scope the changes on the Spinnaker side to just the IMDS proxy toggle, and that's the only thing we had to change over there. Everything else we were able to handle on the orchestration tooling side. Account management is going to be a key part of your migration process, and an interesting note on that piece is that CAMP doesn't tie into it directly, and we think that's generally a good idea. In other words, your account vending process, your account provisioning process, that should be a fairly independent, robust thing that's not driven primarily by a single migration effort, right? So it'll probably require some changes, to facilitate the migration work, but we think it's a good pattern to keep that as an independent process. And the way that ours works is that Spinnaker, for each application or each workload, it asks our account vending machine, which IAM role should this workload in this environment be using, provide some relevant application context, and then the account vending machine will either locate the account that's been mapped to that application using our account inventory, or it will say, oh, it doesn't have one, I'd better go fetch one from our pool, which it will do, make the required updates in the inventory in AWS organizations to add things like account tags, move it to a new OU if necessary, and then hand the role information back to Spinnaker. And then that's how that eventual role assignment makes it all the way back down from account vending to something that the IMDS proxy can be aware of. Please use an account inventory. It makes your life so much simpler. Now, finally, we need a way to interact with this thing, right? So what's the operator experience that we want? Well, it really boils down to two things, right? We want to generate lists of migration targets based on those categories and criteria that we explained earlier, and we want to tell CAMP, go migrate these things. And then we want to wash our hands, right? We want to go get a drink, relax, and let it do all the heavy lifting. To facilitate that, we built a very simple API for CAMP and a validation layer that we'll talk about in a minute. But when we tell CAMP to go migrate an application, it's now going to leverage all of those things that we talked about before, right? It's going to look at the eligibility data, the complexity data to say, what what resource policies do I need to go update? And it's going to go apply those ABAC policies to the appropriate resource. It's going to talk to Spinnaker and say, okay, it's time to toggle the IMDS proxy and do that redeploy. And because this is a migration, it's also time to vend a new account and get a role for that application. And once it's been redeployed, monitor. Is this thing still healthy? And let us know if it's not. Finally, validation, right? There are so many places where things could go wrong, and doing this with large batches of applications could be potentially dangerous, in your environment. So some really, really helpful validation checks that we've implemented into the CAMP API are things like, is the target in an eligible group? Have we gone through one of those state changes where the app is now using a service that it wasn't yesterday and it's no longer safe? If that's happened, even if we submit that target to CAMP, it will just say, nah, I'm not going to touch that. And that's a lifesaver. Are we migrating an environment like prod before test? Sometimes apps have multiple deployments and multiple environments, and if we haven't ensured that every test deployment is done and happy before doing prod, we could cause unnecessary impact. A final thing is, what if all of our checks look good? What if the app is eligible, the test environment was migrated, and everything checks out, but the prod deployment has an unhealthy EC2 instance? There's probably something going on there, and if we were to redeploy at that time or migrate them at that time when they have an infrastructure health issue, we could compound a problem and make it worse. And so that's another type of validation that we've built in, so we're not going to go, make a sore spot even more painful. So now that we've taken a look at how things work end to end, Patrick will wrap us up with some learning lessons and some fun numbers.
Thank you. All right, so some takeaways that we've had. Designing for minimal app owner interaction has really paid dividends here. And the benefits that we were hoping for are real. We made a really big bet with a lot of unknowns, but we're seeing a lot of security lift, operational resilience, platform flexibility, a lot of good stuff coming out of it. The UX benefits are driving grassroots demand for these dedicated accounts. People want their apps migrated, and they're coming to us to ask for that. Organizational buy-in and commitment has been one of the most helpful parts of this for us. Especially from our security and engineering organizations, it's been crucial, really. This should be priority number 0 if you're going to embark on a project like this, because there will be really big roadblocks, a lot of partnership challenges, and you're going to want the top cover. Also, it's been a lot of work. We're about 3 years into this project with Joseph and I as the primary people working on it, and it's been a lot, and you should be prepared for that. So in hindsight, would we do this again? I'm pretty sure we would. I think that's a resounding yes. We'd change a few things, but we really like the solution overall. So a few things that we would change. Get into the migration feedback loop as soon as possible. We tried to make CAMP a little bit too perfect, a lot too perfect, before the first migration, and that slowed us down a lot. If at all possible, try not to do a bunch of other things at the same time, and dedicate headcount to the initiative. We weren't really able to do that because our team is busy. We have a lot going on, and that slowed us down quite a bit. Don't get caught in a project management whirlpool, especially if you have limited resources, limited people working on the project, because that slows things down too. And similarly, minimize external dependencies. All of these are just gonna get you mired in process and trying to communicate across orgs. It can be a lot. And then it's a lot of work. So, few numbers here. We've migrated a lot of services that you've interacted with if you're a Netflix member. To be specific, 405 applications, which constitutes over 1,100 IAM roles that have been migrated. The largest batch that we've done in parallel is actually ongoing right now, and that's 277. And until that batch, this was 0, but now it's 1. But I think that this is still really successful, and we also wanted to show that we're human and we mess things up. But luckily, the outage that we had was pretty minimal, and it was for an internal team service that didn't have any Netflix member impact and barely any Netflix engineering impact. So that's it for us. We really want to thank our AWS account team. They're incredible, and we wouldn't have been able to do this project without them. The cloud infrastructure security team at Netflix, past and present, just an amazing group of people to work with. And thank you all for watching in person, for watching online. Don't forget to like and subscribe. And we'll take questions now.